Welcome to qnawire.
This would be the diagram of the system for the ant, and this diagram is a view from above the wheel. We know that the ant is moving in a curved path, so essentially there's a fictitious outward radial force. We can say omega squared r. That would be this. This would be the outward radial force. We have the ant is moving away from the axis of rotation, so essentially there is a Coriolis force right here. And then the ant is moving with a constant speed, so in the rotating reference frame, the net force is going to be equaling 0 newtons. We know that the ant is in contact with the spoke, so there are actually components of that contact force, a frictional force, and we also have this spoke pushing in the opposite direction to the Coriolis force. So we have a force of the spoke times j hat. So that would be here, force of the spoke. And then in the vertical direction, we know that there is gravity. So we have a force of gravity. This would be, of course, negative mg k hat. This is, of course, our x and y Cartesian axis, so we can't truly represent that on the graph, but this would be essentially in the z direction. And then there's the normal force, of course, Fn k hat. And so these we can say that the force of the rotating frame, if we were to then add these, this would be equaling to m omega squared r minus the force of friction I hat. This would be plus the force of the spoke minus 2 times m omega v j hat plus, and then of course force normal in the z direction, force normal minus mg times k hat. And so this would be our final answer. That's the end of the solution. Thank you for watching.